Story 1. The PRI Reese Map, 1513. In 1513, an Ottoman naval admiral named Piri Reis compiled a world map on gazelle skin. It was assembled in Gallipoli, drawn from what he described as older source charts, some captured, some inherited, some no longer identifiable. Only a fragment survives. That fragment should not exist. It shows the western coast of Africa, the eastern coast of South America, and, at the bottom edge, a southern landmass that does not fit the period's geography. The map was dated, signed, then lost, for 400 years. Then it resurfaced in 1929, rediscovered inside Istanbul's Topkapi Palace during cataloging reforms. No announcement, no press event, just a quiet acknowledgement that the fragment was real. The anomaly appears immediately. The coastline curves south. The proportions hold. The latitude aligns. The southern landmass resembles Antarctica, not as it appears today, but as it would look without ice. Mountain ranges are drawn inland. Coastal inlets match subglacial basins mapped only after the invention of ice-penetrating radar. In some sections, the accuracy exceeds 20th century reconnaissance. This should have been impossible. Antarctica was officially discovered in 1820. Its ice-free topography was not charted until the late 1950s. Piri Reis had neither satellites nor sonar. Longitude measurement at that precision would not be solved for another 2 centuries. So the response was immediate and controlled. Historians propose coincidence. Others argue the landmass was a distorted South America. A few suggested it was imaginary decoration. The most common explanation was safer. The map was a composite, copied from unknown ancient sources conveniently absent from the record. No one asked where those sources came from. When researchers at the U.S. Air Force's Cartographic Division examined the map in the 1950s, internal memos acknowledged a match to Queen Maud Land's coastline. The memos were not published. The analysis stopped. The discussion moved away from capability and toward semantics. The ink was authentic. The geometry persisted. The conclusion stalled. Piri Reis himself vanished into obscurity. After decades of service, he was executed following a political dispute. His estate was seized. His remaining charts disappeared. He missed his final years in silence. His work reduced to footnotes. The map was returned to the archive. Reproductions circulated without context. The most troubling detail, the ice-free southern continent, was reframed as a curiosity. But the measurements never changed. When modern surveyors overlaid satellite data onto the Piri Reis coastline, the agreement was within tens of miles. In polar cartography, that margin is exceptional, even today. One map could be dismissed, but it wasn't alone. Bridge, accuracy confirmed 1958. Classification questions begin. Story 2, the Orange Fine World Map, 1531. In 1531, a French mathematician named Orange Fine engraved a double quartiform world map, 2 heart-shaped hemispheres, symmetrical, elegant, and quietly precise. It was published in Paris, circulated among scholars, and then largely ignored. Not because it was wrong, because it was early, At the bottom of Fine's map sits a massive southern continent labeled Terra Australis. This was not unusual in name. What was unusual was form. The coastline was continuous. The proportions were stable. And the internal geography showed mountain chains and river systems that followed a logic not based on imagination. Fine was not an explorer. He was a cartographer and mathematician. He worked from data. The southern landmass stretches across the map with geometry that matches Antarctica's perimeter more closely than any 16th century conjecture should. Most striking is a segment along the coast that mirrors what is now known as Queen Maud Land, a smooth arc, interrupted by precise inlets, positioned at the correct latitude. This detail would matter later. The symmetry was deliberate. The scale was controlled. The margins were exact. Critics later argued that Fine merely followed classical speculation and ancient belief in a balancing southern continent. But classical models did not include coastlines. They did not include internal structure. And they certainly did not include proportional accuracy across hemispheres. The map's projection compounded the problem. Fine used mathematical transformations that assume reliable longitudinal data. At the time, longitude at sea was guesswork. Errors of hundreds of miles were common. Yet Fine's southern continent aligns with Africa and South America in ways that minimize distortion. This is where the record tightens. In the 19th century, as Antarctic exploration began, Fine's map was reclassified in libraries from geographic to cosmographic. A subtle shift. It allowed scholars to treat the southern continent as symbolic rather than referential. No errata were issued. No formal rebuttal was written. The map simply became less real. Fine himself paid a price of a quieter kind. Despite his skill, he was excluded from major royal commissions later in life. His work persisted in print, but his influence receded. He died without explanation, his most controversial map absorbed into the background of academic history. The coastline stayed. The explanation changed. When 20th century researchers compared Fine's southern outline to modern Antarctic surveys, one segment stood out repeatedly, the Queen Maud Land contour. The match was not perfect, but it was specific, and it echoed a feature already noted in earlier maps. The same curve, the same latitude, the same problem. At this stage, coincidence was still plausible, but the repetition had begun. Bridge. Queen Maud Land contour appears, second independent source. 1531. Story 3. The Haji Ahmed Map, 1559. In 1559, a world map appeared in Venice bearing an unusual signature, Haji Ahmed of Tunis. Little is known about him. No portrait. No confirmed patron. Just a dense, text-heavy map printed in Ottoman Turkish, explaining the shape of the world with unsettling confidence. The map was not decorative. It was instructional. Unlike European charts of the time, Haji Ahmed's map treats the Americas as stable, knowable landmasses. North and South America are proportioned correctly. Central America is narrow, not swollen. Major river systems penetrate inland with accuracy that should have required extensive ground surveys. This was not second-hand rumor. The rivers align. The coast holds. The scale behaves. The southern edge of the map is where the anomaly sharpens. A large southern continent spans the lower margin, drawn as a continuous landmass. Its coastline is smooth, controlled, and, again, structurally similar to Antarctica. Not as a blank mass, but as a place with shape. One section, in particular, repeats a now familiar feature, a shallow arc along the coast corresponding to what modern cartography identifies as Queen Maud Land. The contour is not labeled. It is not emphasized. It is simply there. This matters because Haji Ahmed's map was not derived from French or Iberian sources. The language, projection style, and annotations indicate an independent cartographic tradition. Different culture, different archive, same southern geometry. The response followed a pattern already forming. Later historians categorized the map as a compilation meant for educational use, not navigation. The southern continent was explained away as inherited myth. The accurate Americas were credited to European explorers. The internal consistency was never addressed. No full technical analysis was commissioned. The map's creator faded almost completely from the record. There are no documents describing his training, his sources, or his later life. His name survives only because it was printed. He never returned home. He never published again. He left no letters, no students, no defense. By the 20th century, the Haji Ahmed map was relegated to museum storage, occasionally reproduced for its calligraphy. Its geographic precision was not discussed. When Antarctic surveys began to confirm ice-free coastal outlines beneath the ice, no cross-reference was made. Yet the repetition is now undeniable. 3 maps, 3 centuries early, 3 independent traditions, and the same southern contour. If these first 3 were coincidences, the next map will test that theory. Bridge. 3 pre-1600 maps share Antarctic contour. Error probability collapses. Story 4. The Vinland Map. The Vinland map surfaced quietly in the mid-20th century, bound inside a medieval manuscript known as the Speculum Historiale. No excavation, no dramatic reveal, just a private acquisition that immediately unsettled established history. The map depicts a land labeled Vinland, positioned west of Greenland, across the Atlantic. Its placement aligns with the eastern coast of North America. The date assigned to the parchment, the mid-15th century, decades before Columbus, decades before official contact. Norse sagas had long hinted at western lands. But sagas are not charts. This was a map, with scale, with orientation, with intent. The land is fixed. The latitude holds. The ink is medieval. The implication was direct. Knowledge in North America existed in Europe before 1492 and was stable enough to be mapped. If authentic, the Vinland map would collapse the clean narrative of discovery and replace it with something Messier, overlap, loss, and selective memory. The scrutiny was immediate and surgical. Chemical analysis focused on the ink. One test identified anatase, a form of titanium dioxide, interpreted as modern. Headlines followed. The map was labeled a forgery. Case closed. Except it wasn't. Later studies showed anatase can occur naturally in medieval inks. The parchment dated correctly. The line work matched period technique. The results conflicted. instead of resolution. The map entered containment. Access was restricted. Full datasets were not released. Debate shifted from geography to chemistry, a narrower battlefield, easier to manage. The argument changed. The land remained. The human cost was quiet, but real. Scholars who defended the map's authenticity found funding withdrawn. Careers slowed. One prominent researcher spent his final years excluded from conferences, his work cited only as a cautionary tale. The Vinland map was never formally authenticated. It was never conclusively debunked. It was frozen in dispute. And that may have been the point, because while the debate fixated on ink particles, a larger question went untouched. Why was the geography correct? Vinland's position aligns with Newfoundland. The proportions are restrained. There is no fantasy continent, no exaggeration. If it was a forgery, it was an informed one. If it was genuine, it revealed prior transatlantic knowledge that had been allowed to fade. Either explanation is disruptive. Today, the map sits in controlled custody, reproduced in textbooks as controversial, rarely discussed in detail. Its greatest threat is not what it claims, but what it suggests about how history chooses its winners. The map did not redraw the world. It exposed how easily the world can be redrawn. Bridge, pre-Columbian America mapped. Debate sealed under preservation protocols. Story 5, the Cagnito Map 1402. In 1402, more than 90 years before Columbus sailed, Korean court scholars produced a world map known as the Cagnito. Officially titled Anogangni Yakti Gukdo Jidu, it was commissioned by the Joseon dynasty and intended as a statement of global order. What it became instead was a problem. The map presents East Asia in commanding detail. China and Korea dominate the center. Japan is correctly positioned. This alone is not unusual. What follows is, Africa appears on the western edge, elongated, tapered, and unmistakably accurate. Its southern tip is visible. Its eastern coastline curves inward correctly. The Mediterranean connects as expected. Europe is compressed but coherent. For a map produced in East Asia in the early 15th century, the African outline should not exist at all. Yet it does. The Cape is present. The proportions track. The orientation holds. Portuguese explorers would not round the Cape of Good Hope until 1488. European maps before that date routinely truncated Africa or distorted it beyond recognition. The Cagnito does neither. It shows Africa as a continent, not a hypothesis. Even more troubling is the internal information. Major rivers extend inland. The Nile is shown with branching sources. Mountain ranges appear where modern geography confirms elevated terrain. This is not a coastal trader sketch. The data had depth. The official explanation points westward. Chinese scholars, it is argued, may have obtained geographic intelligence through Islamic intermediaries, Arab traders who traveled widely and shared knowledge across continents. This is the skeptical alternative, and it cannot be dismissed outright. But it does not fully resolve the issue. Islamic maps of the period did not show Africa with this level of proportional accuracy, nor did they typically circulate detailed inland geography to East Asian courts. And even if such data existed, It would imply a global information network far more capable than the historical record admits. The response to the Cognito was containment by classification. In later centuries, the map was framed as symbolic, a political cosmogram, rather than a navigational document. Its geographic accuracy outside East Asia was treated as incidental. Western scholars focus on what it lacked, not what it showed. No comprehensive technical comparison was undertaken until the 20th century. By then, the map's creators were long gone. The scholars who compiled it were court officials, not explorers. They did not travel to Africa. They did not leave memoirs explaining their sources. One of the principal compilers died shortly after the map's completion. His personal records were never recovered. The sources vanished. The map remained. When modern cartographers overlaid the Cognito's African outline against contemporary coastlines, the correspondence was uneven, but directionally correct in ways that predated European confirmation. It was not perfect. It was informed. That distinction matters. If the map was built from rumor, the rumor was precise. If it was built from data, the data moved across continents without leaving a traceable path. Either way, the Cognito undermines the idea that global geography emerged in isolation. By this point, the pattern had shifted. Accuracy was no longer confined to one region, or one culture, or one explanation. Bridge, African coastline map pre, 1488. Knowledge transfer exceeds recorded trade routes. Story 6, the Zeno map 1380. The Zeno map claims to show something that, for centuries, officially did not exist. Published in 1558 by Niccolò Zeno, the Younger, the map was presented as a copy of much older charts and letters written by his ancestors, Venetian brothers who allegedly sailed the North Atlantic around 1380. The voyages, if real, predate most accepted exploration of the region. The geography, if false, should collapse under scrutiny. It doesn't. The map depicts a chain of islands in the North Atlantic, Frisland. Aristotle, Drogeo long dismisses fantasies. For generations, atlases labeled them phantom islands. Proof, critics said, of medieval imagination running ahead of reality. Then the ocean floor began to speak. The islands vanished. The ridges stayed. The depths aligned. Modern bathymetric surveys revealed submerged plateaus and ridge systems in the exact regions where the Zeno map places land. These were not islands in the modern sense. But they were not nothing. The contours suggested landforms that may have been exposed during earlier climatic periods or detected through methods now lost. The map's Arctic geometry complicates matters further. Greenland is drawn as an island, not a peninsula. That distinction would not be universally accepted until the 19th century. Its orientation is imperfect, but intentional. The Zeno narrative was attacked early and often. Historians accuse the younger Zeno of fabrication, motivated by family prestige. The original letters he claimed to copy were never produced. Key sections of the map show distortions. The case seemed closed. And yet, pieces refused to cooperate. The navigation routes described in the accompanying letters match plausible wind and current patterns. The distances between land masses are not random. They cluster. The errors repeat in ways consistent with real travel under primitive conditions. The mistakes make sense. The placement persists. The human cost was buried in the footnotes. Niccolo Zeno, the younger, died with his reputation unresolved, branded either a liar or a misunderstood archivist. His family papers were dispersed. Several documents cited in early reviews no longer exist. By the 20th century, the Zeno map was relegated to margins, taught as a cautionary tale. But when sonar imaging began mapping the North Atlantic seabed in detail, researchers noticed something uncomfortable. Some phantom islands sat directly above shallow banks. Others aligned with fracture zones. Not land, but not invention either. The map had not predicted modern geography. It had recorded an earlier state of it. At this point, coincidence was wearing thin. Multiple maps. Multiple eras. Multiple errors later reframed as approximations. From here on, the pattern stops asking for permission. Bridge. Phantom islands correlate with mapped seabed ridges. Survey data confirms partial accuracy. Story 7. The Wald-Seemuller Map, 1507. In 1507, a German cartographer named Martin Wald-Seemuller printed a wall-size world map that did something unprecedented. It named a new continent across the Western Hemisphere. He wrote America after Amerigo Vespucci, not Columbus. The decision was political, but the geography behind it was technical. Wald-Seemuller did not invent a landmass. He placed it with confidence, scale, and separation from Asia that few of his contemporaries accepted. This was not consensus. It was assertion. The continent stood alone. The ocean was wide. The math was bold. The map shows North and South America as distinct from Asia, divided by an ocean of appropriate width. At the time, many believed the western lands were part of the Asian mainland. Wald-Seemuller disagreed, and he was correct. More troubling is how. The longitudinal spacing between Europe, Africa, and the Americas on the map is restrained. Errors exist, but they are systematic, not chaotic. To achieve this, Wald-Seemuller relied on projection mathematics that assumed access to reliable distance estimates across open ocean, data that should not have been available in 1507. The map was printed in roughly 1,000 copies. Then something unusual happened. Wald-Seemuller changed his mind. In later editions, he removed the name America. He softened the separation between Asia and the Western lands. He retreated from his earlier certainty. No explanation survives. No public correction was issued. The name vanished. The lines blurred. The first version disappeared. Of the original print run, only one complete copy is known to exist today. It surfaced in the early 20th century, preserved by chance in a German castle library. By then, the moment for debate had passed. The human cost was subtle. Wald-Seemuller did not become famous in his lifetime. His most radical contribution was quietly abandoned by its own author. When he died, his earlier map was already treated as an overreach. Modern analysis, however, has been less forgiving to the dismissal. When geographers compared the 1507 map to later confirmed coastlines, the separation of the Americas from Asia proved prescient. The continental proportions, while imperfect, were directional and deliberate. Wald Seemuller was not guessing. He was synthesizing. From where the data came remains unresolved. Vespucci's letters alone do not account for the scale, nor do known Spanish or Portuguese charts. Something else was feeding the projection. By this stage, the pattern had matured. Accurate placement, early assertion, subsequent retreat. The map that named America survived. The confidence behind it did not. Bridge, 1,507 projections separates continents. Longitude precision exceeds accepted navigational limits. Story 8, the Boitsch Map 1737. In 1737, Philippe Boitsch, chief cartographer to the King of France, published a map that should have ended his career. Instead, it was quietly set aside. Boitsch's chart depicted Antarctica not as a frozen void, but as a divided continent. Two large landmasses, mountain ranges, river systems, and channels cutting between them, as if the ice were absent. This was not speculation. It was structure. The ice was gone. The rivers flowed. The continent split. At the time, Antarctica had not been seen, not circumnavigated, not surveyed. No human had recorded its interior. The prevailing belief was simple. If land existed in the far south, it was buried under permanent ice and unknowable. Boitsch disagreed. His map proposed that Antarctica was once ice-free, with a central sea dividing eastern and western landmasses. He based this not on exploration, but on comparative geography, aligning mountain chains, river mouths, and coastal curvature across hemispheres. And then there was the coastline. Along the eastern edge of his southern continent appeared a smooth arc, interrupted by precise inlets. The same arc, the same interruptions. The Queen Maud land contour. Not a guess. Not a blur. A match. This was a breadcrumb planted centuries earlier, now resurfacing with authority. Boitsch was not an outsider. He was establishment, which made the response more careful. Rather than attacking the map directly, critics reframed its premise. They argued it was theoretical, a geographic hypothesis, an intellectual exercise. The accuracy of the coastline was not debated. It was simply not discussed. The silence was strategic. What Boitsch could not have known, what no one in 1737 could have known, was that Antarctica's ice hides a complex subglacial landscape. Mountain ranges, river basins, valleys, all buried under miles of ice. In 1958, during the International Geophysical Year, ice-penetrating radar confirmed it. Antarctica is divided. Subglacial rivers exist. The Queen Maud Land coastline aligns. Boitsch's map was right. The confirmation did not trigger a reassessment of history. It triggered compartmentalization. The map was praised for conceptual brilliance, not geographic accuracy. Its predictive success was treated as coincidence born of intuition. Boitsch himself paid a professional price. After publishing the map, his influence declined. He remained employed, but sidelined. His later work avoided the Antarctic question entirely. He died respected, but diminished, his most dangerous idea left behind. He stopped drawing south. The implications were now unavoidable. 3 earlier maps had shown the same southern contour without explanation. Boich repeated it with refinement. Centuries later, satellites verified it. Different eras, different methods, same result. At this point, coincidence no longer fit the data. The maps were not imagining Antarctica. They were remembering it. Bridge, Subglacial Confirmation 1958 to 1737 map, matches radar beneath Antarctic ice. Story 9, the Mercator Arctic map, 1595. In 1595, 1 year after his death, a map attributed to Gerard Deus Mercator was published showing the Arctic as no one had ever seen it, and, officially, no one ever had. At the top of the world, Mercator drew 4 large islands arranged around a central black mountain, separated by powerful radial channels. The North Pole sat at the center, marked not by ice, but by structure. The map included currents, directional flow, and symmetry that suggested measurement, not myth. This was not medieval fantasy. The channels were ordered. The center was fixed. The scale repeated. For centuries, the map was dismissed as allegory. The 4 islands were labeled imaginary. The central mountain, Rupi's Niagara, was treated as a symbolic artifact, borrowed from legend. No one expected the Arctic to cooperate. Then came sonar. During Cold War-era submarine surveys, U.S. and Soviet vessels began mapping the Arctic Ocean floor. Beneath the ice, they found a system of ridges and basins. The Lomonosov Ridge, the Alpha Ridge, structures radiating from near the pole. Not islands, but not random either. The spacing of these features echoed Mercator's 4-fold division. The central elevation was not a mountain, but a convergence of bathymetric highs. The map was not literally correct. It was directionally precise. This is where the earlier pattern snaps into focus. Mercator claimed his Arctic data came from older sources, specifically a now-lost 14th century map and a description attributed to a Franciscan friar who claimed to have traveled near the pole. That source vanished. The claim was set aside. But this was the same method cited by Pyrie Reis. Older charts. Captured knowledge. No surviving originals. The humane cause followed the familiar script. Mercator spent his later years under suspicion, accused of heresy and briefly imprisoned. His papers were scattered. Some never recovered. The Arctic map was published only after his death, when he could no longer defend it. He never saw the fallout. When modern geophysicists overlaid Mercator's Arctic geometry onto sonar-derived ridge maps, the tolerance was not exact, but it was intentional. The 4-fold symmetry aligned with real tectonic features. The flow patterns mirrored oceanic currents later measured under the ice. And then the callback closed the loop. The same cartographic logic that shaped Mercator's Arctic, projection from unseen structure, had shaped the southern map centuries earlier. Pyrie Reis had hinted at it. Boach had formalized it. Mercator applied it at the opposite pole. North and south. Ice-covered. Mapped anyway. By now, the escalation was undeniable. These maps were not lucky. They were consistent. They did not guess blindly. They worked from a model of the Earth that assumed hidden terrain could be drawn. And in both polar extremes, modern instruments eventually agreed. Bridge, Arctic Seabed Map 1960s. Mercator geometry aligns with sonar-confirmed ridges. Story 10, the Cantino Planisphere, 1502. In 1502, a world map was stolen. Alberto Cantino, an agent for the Duke of Ferrara, bribed a Portuguese cartographer to obtain a copy of Portugal's most closely guarded document, a master nautical chart compiled from state voyages. The result was the Cantino Planisphere. It was never meant to leave Lisbon. It did anyway. The map shows the Atlantic world with startling clarity. Africa's coastline is sharply defined. Brazil appears years before it was publicly acknowledged. The Caribbean is organized, not speculative. This was not an explorer's sketch. It was an intelligence product. The coastlines were clean. The secrecy was explicit. The penalty was implied. Portugal did not deny the map. It changed policy. From this point forward, cartographic knowledge became controlled. Sea charts were classified. Copying was restricted. Punishments were severe. The age of open geographic exchange ended quietly, replaced by state monopoly. This is the hinge. Because the Cantino Planisphere proves that highly accurate global maps existed behind closed doors, while public versions lagged decades behind. The gap between what was known and what was shared was deliberate. And the map contains a final anomaly. The southern Atlantic is proportioned with restraint. No bloated continents. No fantasy land. The geometry echoes earlier maps, suggesting access to a broader reference system than Portuguese voyages alone could supply. This was not built from scratch in 1502. It was inherited, updated, and locked away. The human cost was invisible but lasting. The anonymous cartographer who leaked the map vanished from records. Cantino returned to Ferrara with the prize and never explained his methods. Others who tried similar thefts were executed. The archive closed. From this point on, maps diverged. Public charts simplified. State charts sharpened. Older anomalies were reclassified as errors. This reframes everything that came before. The Pyrie Reis map was not an outlier. The Antarctic contours were not accidents. The Arctic geometry was not myth. They were remnants of a knowledge stream that predated modern nations and was later fenced off. The Cantino Planisphere marks the moment the fence went up. What followed was not ignorance. It was management. And once knowledge is managed, history becomes editable. That is where the story ends, and where the question begins.